And thank you so much for coming to the JCC of Greater New Haven for our first support group for Parkinson's. And we are honored to have Michael J. Fox Foundation here for our first support group. I'm going to introduce some people that behind the scenes helped out a lot. My director. She did most of the work for me. And by the way, my name's Terry. I am the Assistant Director of Fitness and also a Parkinson's specialist downstairs. So I work with a lot of Parkinson's people exercising. And you'll learn that today, that exercise is the most important thing for Parkinson's. We have our Michael J. Fox Foundation girls who are going to present to you. We have Rachel. Now, if you look at the two of these, they look almost like twins, right? They're sisters.
This is our connection.
This is our connection to Michael J. Fox Foundation. So this is Rachel, and this is Fega. And they're going to take over the presentation for you tonight. And if you have any questions after, feel free to grab me. I'll be out in the back. Okay, thank you.
Thank you. Hi, I'm Vega Bursman-Taylor. I'm a Senior Associate Director at the Michael J. Fox Foundation. And this is my colleague. I'll let her introduce herself real quick.
Hi, I'm Rachel Winkler. I am the Director of Leadership Gifts at the Michael J. Fox Foundation.
Great. So I always like to start off our presentations with a quote from our founder, the actor Michael J. Fox. And he once said that our challenges don't define us, our actions do. And I look around this crowded room and I see people who've already today chosen to take a positive action and learn more about Parkinson's disease and the entire Parkinson's community. So hopefully this will be the first of many steps, many positive actions that will really define our journeys together. And I'll hand it to Rachel to discuss the foundation.
Thank you, Vega. Thank you guys all for joining us today on this beautiful, sunny day. How many of you are familiar or have been involved with the Michael J. Fox Foundation before? Oh, that makes us so happy. Well, welcome back. For those of you that aren't as familiar with the foundation, we were started in 2000 by actor Michael J. Fox. And Michael was diagnosed with early onset Parkinson's, and he really thought it was his objective in life to do something and to use his voice and his platform for Parkinson's. And so he teamed up with our co-founder and CEO, Debbie Brooks. And together they realized, well, there's so many incredible Parkinson's community organizations and foundations, very few focused on the urgent need for research and drug development. And so here at the foundation, we really strive for better treatments, better policy, and better trials. And that is our biggest mission. We are the largest Parkinson's funders in the world. We have deployed over $2 billion to research in just 24 years, which is really, really incredible. And we really aspire to go out of business. We want to find a cure. And so, within any dollars that come into the foundation, within 90 days, that's handed over to a scientist and a research so that they can continue to find better treatments. And 88 cents of every dollar goes directly to that, so we're really proud of that. What makes us different? Top of mind is you. It's people who are living with Parkinson's, and we are collaborators. We are bringing, scientists and business-minded people in the field together to really identify what do we need today? What is top of mind? What are people struggling? What is gonna make you feel better? Is it gait and balance? Is it sleep? Is it walking? Is it swallowing? What are the problems we're seeing where there's not enough treatments to help you with your day-to-day? And so we really evaluate that on a daily basis, a yearly basis, with people across the country and across the globe to make those decisions. And we fund an aggressively a research agenda to make sure that those are happening. And we want to make sure that all of our grantees are, open. So we believe in open and reproducible data. So something that's happening in a lab in, say, Australia, somebody here in Connecticut is able to have access to what is going on in that lab, so that we're not, repetitive, and we're really using the resources around our experts. If you see here, this is kind of our business model per se. And again, no one person can do this. But here at the foundation, we believe in being bold and taking risks. And so if not us, then who? And that's kind of our motto. We are gonna raise our hand and be like, let's fund it. Let's see what can happen. We are milestone driven, and we believe in better processes to make sure that is happening. Just to give you an example, about 20 years ago when the foundation was started, it would take about 27 years for something of an idea to then go through a clinical trial to then end up on shelves to be a treatment for you today. We've been able to help cut that timeline in half, and it now takes about 12 years. And about 18 new treatments have come to shelves in the last 8 years, so it's really incredible. And we hope to cut that down even further, and we'll talk about that. We'll talk about that a little later in our research update. So just to pause and kind of take a step back, I wanted to talk to you guys about what is Parkinson's disease. And so many of you here today who have been diagnosed might have first realized a tremor, or slowness, or stiffness. Well, what's actually happening in the body? What is the biology of Parkinson's? How many here today have ever heard of the word alpha-synuclein? Wonderful. How many of you have heard of dopamine? A few more. This is kind of playing for me. Sorry about that. So alpha-synuclein and dopamine kind of go a little bit hand in hand. Alpha-synuclein is the hallmark pathology of Parkinson's. But everybody has everybody has alpha-synuclein. It is in everybody. It is found all over the body. So it's in the gut, it's in your skin, it's in your brain. And when we think about this alpha-synuclein, when we look at somebody who has been diagnosed with Parkinson's, we are noticing this clumping, this misfolding of this protein. So if you think of like a printer and it's printing paper, then all of a sudden you get one of those paper jams and it just keeps jamming up and jamming up and jamming up, you can't fix it. That's kind of what's happening with this alpha-synuclein. And so when that alpha-synuclein begins to clump, researchers call that Lewy bodies. And it's believed that Lewy bodies are toxic to the body. And the toxicness of the Lewy bodies is killing off of these dopamine cells. So the loss of dopamine is present. And so what does that mean? Dopamine controls many different parts of the brain, right? It's where you're feeling, it's your apathy, emotions, sleep, movement. And so when you lose this dopamine from the clumping of the alpha-synuclein, these Lewy bodies, that is why you're feeling that slowness or that tremor. It's a direct cause of the loss of dopamine. So you might be familiar with some of these symptoms. You might have been experiencing some of them. A lot of the times we talk about motor symptoms in Parkinson's, so that is directly related to movement. But there are other symptoms associated with Parkinson's that are related to Parkinson's. And so I encourage you, if you have any of these symptoms that you didn't realize are associated with Parkinson's, to talk to your doctor, because there's lots of different treatments to handle each and all of these. But I'm just going to talk a little bit more about dopamine. I'm going to use an example of a fishbowl analogy. So if you have a fishbowl and goldfish in it, goldfish are your dopamine cells, and they unfortunately keep dying. We can't seem to keep these goldfish alive. And so we can continue to replace that goldfish. So that's the medicine many of you probably are taking today, your levodopa, carbidopa, your Cinemet. That is replacing the dopamine in your body. But until we are able to change the environment, replenish that water, figure out what the underlying problem is, we're not able to stop, reverse, or modify the disease itself. And so alpha-synuclein is our best target today to do that. And that is one of the biggest things that the Michael J. Fox Foundation is funding. And I'm gonna pass it over to Vega, who's gonna give an amazing research update and walk you through some of that stuff.
you, Rachel. That was like an amazing background. But during this research update portion, we're gonna kind of like dive right into the meat of what we're doing. You're probably wondering, like, what is this research? What are they funding? You know, we're talking about these large amounts of money, no endowments, money in, money out. Where's it all going? I'd like to take a moment, and when we think about research, sometimes people will start off the conversation by asking me, or I'll ask people like you know, what is a cure? We're talking about the mission of the foundation to find a cure. What does that actually mean? I get a lot of different answers to this question, and the truth is a cure can mean different things to different people. Some people say to me, you know, Vega, if you put a pause button on my symptoms right now and you told me I would not continue to progress, I'd consider that a cure. Some people say, you know, Vega, I want one treatment and that's it. I can forget this ever happened to me and I'm like I was before this diagnosis happened. That's a cure. Some people say, well, I'd be okay taking the pill every day for the rest of my life if you kept it at bay. So cure can mean different things to different people. But here at the foundation, we've created sort of a roadmap, and that follows the trajectory of Parkinson's progression. So when we talk about a cure or better treatments for symptoms, and we're looking at people who are either just diagnosed or in those earlier stages of how they're feeling, we're looking to slow down or stop their progression, to either, you know, put that pause on or at least give them longer amounts of time before they get to the next stage of Parkinson's. When we're speaking to people who've had Parkinson's for a few years and it's sort of at a middle stage or they see that they're starting to progress, we're looking to help them dial that back, to replace those dopamine losses, to help them restore, you know, some of what they felt before that progression set in. And we're also simultaneously thinking long term. We see a world without Parkinson's, so we are spending a lot of time and energy on prevention efforts. We'd love to find a way to identify Parkinson's before it's been diagnosed, and we'd love to create interventions so that people don't have to experience the onset. Those are some things to keep in mind as we continue to use words like cure and treatments. Now, Rachel told us a bit about alpha-synuclein, and that is a wonderful target that we have when we talk about slowing or stopping progression. You know, researchers looked at people with Parkinson's and they asked that question, you know, we know that dopamine's been affected, but why? Why has it been affected? Now, this culprit of alpha-synuclein, perhaps if we tackled it, we can help you retain dopamine levels that you currently have, or perhaps when we put in dopamine replacement therapies, which till now have failed because you're just putting dopamine back into a toxic environment, so, you know, it's not going to thrive, you know, maybe then it will work. So we are currently working on a lot of treatments for alpha-synuclein. There are currently 13 trials in therapy right now. And these 13 trials, they're not all doing the same thing. There are 13 different shots on goal. You know, there are some antibody approaches. We're looking at ways to de-aggregate those clumps. We're looking at ways to flush them out of the system. I feel like that should give you a lot of hope. There are 13 different things that are currently in clinical trials, which means they're in the last stages of the research process, that might be able to deal with this culprit, to allow you to create a flourishing environment for dopamine. So that's something that's really exciting, and that's one of our most promising targets, but it's not our only promising target. The Michael J. Fox Foundation is also funding a large portfolio of research that pertains to genetic markers. We have these targets. Some of you may have heard of certain genetic mutations that are associated with Parkinson's onset. What I like to tell people when we talk about genetics is, even if you have a genetic mutation that's associated with an onset of Parkinson's, that usually only means you're about 30% more likely to develop Parkinson's. It's not by any means, you know, oh, I carry this genetic marker, I'm consigned to this, you know, diagnosis at some point in my life. And when I speak to people who are worried about passing it on to their children, that's something that I like to mention. But a question that I actually get asked more than that is, most people with Parkinson's don't have a genetic marker. 90% of people with Parkinson's have what we call idiopathic Parkinson's, which means we're not quite sure why they have Parkinson's at all. So we're pouring a lot of time, a lot of attention, and a lot of money into a portfolio on genetic targets. But actually most people with Parkinson's don't have a genetic target present that we know of right now anyway. So some people ask me, well, why are you doing that? Shouldn't you be concentrating on the vast majority of people with Parkinson's? So, great question, glad I asked it. So what I like to do is actually dial it back to alpha-synuclein for a minute. Do you ever wonder how we know what we know? Well, how do we know about alpha-synuclein? How do we know about this culprit? There are so many things that are happening in the body. How are we able to identify this target for research? And it actually is a story that goes back not too long ago to the 1990s. Researchers were able to identify a family, the only known family in the world. I believe they lived in Italy. And everyone in that family would at some point go on to develop Parkinson's disease. Not seen anyplace else. We were able to study their DNA, and we know that synuclein is a protein, as Rachel mentioned, but it also expresses itself as a gene. So by studying this family, we saw there was a mutation on our synuclein gene. Now, even though they are the only known family with a synuclein mutation, they were able to tip us off. Maybe if synuclein is the problem with this family, we can look at synucleinopathies in everyone with Parkinson's, and lo and behold, we were able to identify that synuclein, even in people with Parkinson's who do not have that genetic marker, was still acting abnormally. That is the very reason why we pour so much time, attention, and money into looking at genetic markers. It's almost like a cheat sheet. Or sometimes I'll describe it as like a recipe. You know, ooh, my cake came out a little flat. Sorry. My cake came out a little flat. What happened? Well, I go back to the recipe and I say, ooh, you know what? I put in a little bit too much flour. Ooh, I left out that cup of sugar. And that shows you, what you can do next time to make it better. So by looking at genes, what we're hoping to do is identify a culprit that we can then prove to be helpful to everyone with Parkinson's disease. And this is something that we've seen happen with a number of other neurological disorders, so it's kind of a tried and true method. And that's why we spend so much time, money, and attention on genetic targets. There are two genetic targets that are probably the ones that you hear about the most. They're called GBA and LRRK2, or LRRK2. We have a couple of clinical trials, currently human clinical trials, where we're trying to investigate potential to see if we can tamp down anything that's sort of like overactive, or we can, dial up anything that's underactive. And the hope is that if we sort of perfect that, that's something that everyone with Parkinson's can benefit from. So we'll keep our eyes on those. And then at any given time, the Michael J. Fox Foundation can be funding up to 800 different grants. So obviously not everything that we're doing is about alpha-synuclein or genetic targets. We actually, as much as we know that there's so much we don't know. So we're pouring a lot of time and money into looking at the underlying biologies, into looking at cellular processes, and a lot of these other areas that we're interested in. You might see some like splashy headlines about them. The one I get asked about most is inflammation. Inflammation is sort of like toxic byproducts or things that affect your microbiome. We know, as Rachel pointed out on her slide, that people with Parkinson's, very often, years before onset, they'll start experiencing some digestive symptoms. So that's kind of a clue there might be something going on that we can rectify there. And just in general, when we look at alpha-synuclein acting abnormally through the cell, maybe it's a good time for us to take a look at the actual cell. Maybe people with Parkinson's have, an issue with their lysosomal systems or with their mitochondria. We're always looking at cell repair because maybe there's something we can do to the cell to stop these aggregations. So we have a lot going on. We have a lot that we're covering. And what we always like to do is really cast a wide net. We have this de-risking model, so we want to look everywhere. We don't want to put all of our eggs in one basket. So hopefully hopefully that's a bit of an overview of the different places and the different sorts of promising things that we can expect ahead. Now, as we were looking to identify all of these different areas that we deem promising for a cure or for better symptomatic treatments, we encountered a couple of roadblocks. You know, there were just some field-wide challenges that came up again and again. And so we decided, you know, we couldn't just start and stop with the research. Maybe there was something that we could do that could affect the entire landscape and make it easier for us. Like, for instance, what are some of these major roadblocks to finding a cure? It wasn't enough to just look at the science. We also had to look at the research landscape in a more holistic manner. One of the biggest issues that we found was with diagnosis. And I have had so many different stories about people coming over to me and saying, oh my gosh, diagnosis for this was a nightmare to me. You know, I was misdiagnosed, or I was sent to this doctor, I was sent to that. Everyone has a diagnosis story. And for years, what diagnosis would look like is you would have some symptoms, you would go to your neurologist, maybe like a movement disorder specialist, hopefully a movement disorder specialist. They would have you walk up and down a hall. They would have you go like this with your fingers. And then you would find out this sort of like life-changing news. And someone once said to me something that really resonated. He said, you know, it was just so unscientific. I went there, I had somebody observe me, and my whole life was changed, you know, and it was unscientific. And that resonated. We realized what we need, what would really help change the landscape here, is something called a biomarker, a diagnostic tool. And that's something that we see in like a number of other fields. A biomarker can look like an X-ray to make sure you have a broken bone. It can look like checking your blood sugar to see if you have diabetes. There was no known biomarker. You just had to rely on the expertise of a movement disorder specialist to observe you and kind of like grade you on a scale. So it was open to some biases. Sometimes when a movement disorder specialist wouldn't know if you had Parkinson's or not, they say, take this medication. If you feel better, you have Parkinson's. So the Michael J. Fox Foundation decided to launch something called the Parkinson's Progression Markers Initiative, or PPMI for short. We launched it in 2010, and what it was is just a large-scale observational study, meaning like there's no therapeutic given, there's no drug given. We just look at you over the course of at least 5 years, so your sign-on would take a long time, and we would mark down any kind of data that we could, any kind of measurable that we could, and try and find patterns, try and find something trackable amongst the entire population of people with Parkinson's disease. It was a tall order. We collected tissue samples. We tried to measure people walking up and down hallways in a better manner, you know. And over time, we collected what is the largest data set and the largest biosample library of people with Parkinson's in the world. Speaking again to Rachel, talking about our open science model. These biolibraries, these data sets, were freely available to anyone who wants access to them in the world, including people like you. They are downloaded on average 2,500 times a day. And last time I checked, this information had been downloaded over 14 million times. Now, I just like have this, I sometimes imagine that there's someone like curing Parkinson's off in a room using this data that we don't know about, and there will be a big announcement. But it's really just been an incredible undertaking for us. And we soon realized 10 years into PPMI, it wasn't enough. So we decided to expand in 2020. We grew to over 50 sites internationally, so all across the globe. Whereas our goal was 1,400 participants, we now have a goal of 2,000 participants, or 4,000 participants, sorry. We have about 2,000 participants, so we've got plenty of room to grow. And we also included an online platform that anyone above the age of 18 in the United States can participate in. Now, we are currently recruiting for this clinical trial. So if you meet any of this criteria, I would encourage you to visit or reach out using this web address at the bottom of the screen or this phone number at the bottom of the screen. The people that we are looking for to participate in person in PPMI are people who've been recently diagnosed. That means people who've been diagnosed within the last 2 years. People with Parkinson's risk factors. Risk factors include things like the genetic markers that I talked about, a loss of a sense of smell, people with REM sleep behavior disorder, and we're also looking for control volunteers, and those are people with no known connection to Parkinson's whatsoever. We're collecting all of this because we need a biomarker. We need a better, easier way for us to diagnose Parkinson's so people don't have these stories anymore. Now, we went full throttle with PPMI, and you may have seen some headlines that came out last year, but I'm very excited to announce we found a biomarker. So this was announced just about a year ago to this month, a year ago this month. And our biomarker is a tool that we call the alpha-synuclein seeding amplification assay, or SAA for short, because that's a mouthful. Now, what this biomarker does is it uses alpha-synuclein, which you've heard so many times today, and it takes the samples that we had from people with Parkinson's and PPMI, and it mixes it with a synthesized version that's just created in a lab of alpha-synuclein that doesn't have any clumping in it. What we do is we will mix those two samples together, and if we see that the aggregated alpha-synuclein from someone with Parkinson's causes the synthetic alpha-synuclein to clump, that is a positive indication of Parkinson's disease. So the unfortunate part of this wonderful tool is that we garnered these samples from cerebral spinal fluid. So we actually got them by administering a spinal tap, which is not the most comfortable way to get these tissue samples. So this is obviously something that's not really readily available for everyday clinical use. But it's promising because we know it can be done, and we know we have the chemistry of it right. So what we really need to do is sort of perfect a mechanism so we can make this biomarker more readily available. Now, the biomarker, how are we going to use it? You know, what's it going to do for our research landscape? Our hopes are these will make clinical trials faster, smarter, and cheaper. Now, when I talk about a misdiagnosis for someone with Parkinson's disease, when it comes to your personal journey, that could be, devastating enough. But what if there are people who have a misdiagnosis of Parkinson's disease and then they enroll in a clinical trial for a therapeutic, and that therapeutic fails? Is it because of the therapeutic, or is it because it's being tested on the wrong people? So this biomarker is as invasive as it is. We're already introducing it into clinical trials to make sure that clinical trials are being tested on people with diagnosable Parkinson's disease, to make sure that these therapeutics are being tested on the correct population. This will in turn make trial outcomes clearer, so we can see if those treatments are working more quickly. It's also a way for us to tell in real time, is this working? Think about it. Clinical trials until now had to rely on people saying, I feel better, or I don't feel better. There's no way to sort of measure whether or not you're actually doing better. We all know about placebo effect. So this could be a real game changer for a cure and for streamlining therapeutics. We also have hopes of early detection, harkening back to my earlier slide. What does a cure look like? Obviously, early detection can help us nip Parkinson's in the bud. Perhaps we can diagnose it before those symptoms set in so that you don't have an onset. So there's quite a lot that we're depending on here. And our roadmap forward with this biomarker is we hope to continue to integrate it into clinical trials so we can do all of the things that we recently discussed. We also recently, about 2 months ago, we published an article in a medical journal on staging. staging is something that we're all familiar with because we talk about it with cancer. You know, there's a difference when somebody's diagnosed with stage 1 cancer and somebody's diagnosed with stage 4 cancer. We can see a world where we can do something similar with Parkinson's disease, you know? So this article sort of laid out a staging process from stage 0 to stage 6. Well, when we look at these alpha-synuclein aggregates and we're able to tell how they're doing, whether they're growing or receding in the body, that could help us with staging so that we can meet people in their Parkinson's diagnosis and treat them as aggressively as possible so they feel as good as possible with where they are. Now when you're diagnosed with Parkinson's, you know, everybody sort of starts out the same way with the medication. So this will be a greater way to create precision medicine and introduce that into Parkinson's diagnoses. And then lastly, we're hoping to fund research that will deepen our understanding of Parkinson's and also Parkinsonisms. We know that there are several things that look like Parkinson's, which can lead to misdiagnosis. So subtyping would be greatly helpful because we'd be able to tell you what kind of Parkinson's you have, where you are in that Parkinson's journey, and again, create a really aggressive, personalized care plan. That's kind of where we are with the cure. But how about people who are living with Parkinson's today? You know, what can we look forward to? Well, I just want to point out some of the Parkinson's therapies that are currently available on the market. Now, if you look underneath, you'll see there's a timeline, and if you look on the side, that's the names of the medications. There are currently 40 treatments for Parkinson's disease, and this is something that a lot of people don't know. With Parkinson's, you know, we treat your dopamine loss, but we also have to treat your symptoms as they come. For about 50 years, not over 50 years, for about 50 years, since Parkinson's, you know, first medication came on the market, there were 7 different treatments for Parkinson's disease. Since the Michael J. Fox Foundation has been on the scene, there have been over 30 new approvals, many of which we've had a hand in. If it's not directly with funding, then it's with connections, then it's with, you know, advisory capacities. And so I'd just like to introduce this. If people want to look at these slides afterwards, we can happily distribute them. But I'd like people to know there are so many options, and very often in your personal journey, it can feel stagnant, but there's actually quite a lot you can look into, and we're happy to share this information with you. And with all of those drug therapies, we're actually not done. There are a number of therapies that are coming down the pike. So I just want to highlight a couple because I know sometimes we're all looking at headlines. And so here's a couple of things that you might want to look forward to. There are currently 2 different therapeutics that are currently with the FDA for approval. And then there are 2 therapeutics that are in the last phases of clinical trials. So one that's with the FDA for approval now, and one that's in the last stages of the clinical trials, is a subcutaneous pump. And what that does is it takes medication that you're already taking, and it just sort of converts how you take it. For a lot of people, taking a pill might not be the best way for them to take medication, because as we said before, digestion can sometimes be an issue. So think about it. We're taking a pill. We have compromised digestion. It has to break down in the digestive system. It has to cross the blood-brain barrier, find where it needs to be. You know, if you digest too soon, you can use up that medication too quickly. And if you don't digest it quickly enough, you're kind of also left with too low of a dosage for what you need when. We call these on and off periods. Off periods might be something that you're familiar with. That just means your medication is not working the way that you need it to in the time span that you need it to. So these subcutaneous pumps, they work in a way where we're cutting out that entire digestive process, and we just have a steady stream of medication that's going directly into your body, with sort of cutting out that heartache. We also have another pill that's coming down the pike, so keep your eyes open for it. It's the amniol study over here. And that's also levodopa carbonate. carbidopa, which is the replacement for dopamine. And the way that this pill is different is when you take it, it gives you an immediate dose of the medication, but it's also formulated so that it has an extended release dose of the medication at the same time. So by taking one pill, it will actually last longer and hopefully will cut down on some of the medication that you need. So these are some things to look out for. Those trial results we should be hearing about by the end of the year. And then also you can, look at the other two studies. And if they pass that phase 3 of clinical trials, we can look forward to seeing them go to the FDA for approval as well. Other therapies that are on the horizon, things that are sort of novel that we want to keep our eyes on, are the Atom company. Now, we know that people with Parkinson's exhibit a lot of symptoms that aren't related to movement. And one that we see a lot are throat issues. So very often we will tell people that they might want to ask a speech therapist to help them with these. But the Atom company has actually used some interesting technology involving vibrations to create a technological device to sort of push or kind of like trick your brain into you acting in a way that you normally would. We believe that it's Parkinson's that are causing issues with either eating, swallowing, drooling, speech, and perhaps by putting this device over here, as you see it in the picture, and using vibration technologies, it can sort of bypass any issues that you might have, sort of like a trick methodology. We find that a lot of different devices that are targeted at Parkinson's use vibration technology, and it works for a lot of people. The company Takeda is actually also coming up with an interesting new therapeutic. This is a pill, and it's actually to tackle issues with Parkinson's cognition and Parkinson's gait. The Michael J. Fox Foundation a few years ago put out a survey to people with Parkinson's, and almost 70% of people responded, which is an overwhelming response, that the issue that they had the most trouble with was gait imbalance. And that was very troubling because that is an immediate safety concern. And we also kind of thought that was not something that you could take a pill to help with. So we poured a lot of time and energy into coming up with different sorts of tech gadgets to help people with their gait imbalance. But we were really heartened because this Takeda study looks really promising. What they're doing with this pill is they are encouraging production of acetylcholine in the body, and they believe that that will help with Parkinson's gait issues as well as Parkinson's cognition issues. So this is something that we find really interesting and we want to keep our eyes on. And then that pump that I was just telling you about that sort of like circumvents the need for a pill, there's just a little picture of it here, and you see it goes around your waist like a belt, and then you have like a little pack of the medication, and then it goes straight into the stomach via tube. All right, I feel like I've been talking for a very long time, so I'm gonna hand it back to Rachel to tell you more about what we can do today.
Thank you so much, Vega. That was amazing and very, very hopeful, and I hope you guys all are as well. So what can we do today? What is going to help us feel better? The most important thing you can do is to take care of yourself and to continue to do the things you love. Exercise, as we mentioned before, is the only known treatment right now that can help slow progression of Parkinson's. It makes your body feel good, right? So the best exercise that you can do is the one that you want to do, the one that makes you feel good. That might just be going for a walk with a friend. That might be coming and seeing Terry and doing a workout. That might be joining a Zumba class or, watching a video and just stepping to the beat. Whatever movement helps you feel good, that's the best exercise for you. And there's lots of people that can help you work with that. Diet. We constantly hear exercise diet, our whole lives, right? Everyone says that's the best thing for you. It really is. And so for diet, you really want to eat, the rainbow. Lots of colored foods, whole grains. For those living with Parkinson's, the Mediterranean diet has been shown to be really beneficial. But as Vega mentioned, a lot of digestion might be an issue or a complication. And so it's important to talk to your doctor about that as well, because when you eat food and when you take your medication, the timing of that and what you're eating can also play a role in how you're absorbing your medication. So if you don't feel like you're absorbing your medication, it might be the food you're eating or when you're eating it timed with your medication. So I encourage you to talk to your doctors. And that brings up building your care team. We talked a little bit about, Vega mentioned movement disorder specialists. What is a movement disorder specialist, right? So they are neurologists who focus on those living with Parkinson's. So if you go see a neurologist, they're seeing all different types of neuro disease throughout the day, right? They're not only seeing people with Parkinson's. A movement disorder specialist is only seeing those with Parkinson's. So they're able to kind of see you and help you with your journey. Everyone's journey is different. We have this saying at the foundation, if you've met one person with Parkinson's, you've met one person with Parkinson's. Everyone has a different impact, different treatments, the way your body moves, the way you react to medications. So really important that you build the right care team, and that might also include a physical therapist, a counselor, a nutritionist, occupational therapist. All of that is going to be super helpful. And then do what you love. If you love seeing friends and family, if you love coming to the JCC, if you love playing games, going for a walk, continue to do what you love. So often a side effect of Parkinson's is depression or wanting to stay home, not feeling motivated to do anything. I encourage your family and friends to encourage you to go out, to continue to do the things you love. That is going to help you so much, and it's going to continue to make you happy and live your best life. Different ways to get involved with the Michael J. Fox Foundation. We'd love for you all to join us. There's so many different ways. I'll just talk through a couple of the programs that we do have. So the first is our Buddy Network. It's an online platform, so you can communicate with those around the world, here in New Haven, wherever, and it's just an online platform. You can share, what you're dealing with. You can ask questions, you can answer questions. It's also for those, caregivers, right? You're not alone. We understand that living with Parkinson's affects more than just the person living with Parkinson's, and so this is really an amazing community, and it is an online platform, so you can get involved wherever. We want to make sure that you feel educated. You have questions, but your doctors are so busy, they can't answer your call every single day when you have a question. We've got an amazing education program of webinars and podcasts. We host a new webinar every third Thursday of the month. So if you sign up on our website to receive emails, if you've signed in and you checked the little box to get emails, we'll make sure that you're on that list, and you can stay up to date. And when the topic interests you, you can always watch it on demand as well. And then podcasts. So we have podcasts from our scientists and our research, kind of sharing what's happening today, tomorrow, exciting things down the line, but also from our patient council. And people living with Parkinson's today, kind of sharing their journey, what they're experiencing, what's motivating them, and how they're kind of doing. Another resource we have is Ask the MD. So we have on site Dr. Rachel Dolan, who is a movement disorder specialist, and we listen to the community. So we will put out a survey of like, what are you interested in hearing? What is the latest that you need more resources on? So we just put out a video about sleep and how sleep can help you in your everyday life. So there's tons of videos with Ask the MD. I think she recently just did a diet guide, and then there's also an exercise guide. So all of those resources can be found for free online. Vega talks so much about clinical trials, and we can only move through the pipeline as fast as we can with the right people in those trials. And so we are always looking for volunteers. And so if you fit the criteria, we would love for you to raise your hand and participate. So you can always go to Fox Trial Finder to see what is in the works. I do know today that there are 4 trials recruiting in the New Haven area for Parkinson's and cognitive clinical trials. So if those are of interest to you, I highly recommend you go onto this website and see if you might be a good candidate. We're going to do questions in just a couple of minutes. I promise we're almost done. There's so much information, I know. Team Fox is kind of our grassroots. So it's a way for you to, gather your friends and family to raise money. This could be by, putting on a little tournament. It could be by participating in a marathon. Lots of different ways. We have a whole do-it-yourself series, and we're happy to help you through that. And then, of course, we are a foundation, so donations are very important. I will say the average gift that the foundation receives is $50 a person. So no gift is too small. Your dollar really makes an impact. Like we said, 88 cents of every dollar goes directly to research within 90 days. So we really are moving the needle as quickly as we can. And I'll just end with advocacy. I don't know how many of you are familiar with the National Plan to End Parkinson's Act, but it is a major thing at the foundation that we are advocating for. So the National Plan to End Parkinson's was passed the House of Representatives, huge win, yay, and the Senate will vote on it next. Just so you have a frame of reference, Parkinson's costs about $52 billion, and the government currently invests about $250 million a year. So we really want to advocate so that they invest a lot more, so that we can do a lot more.
Is it 52 billion annually? Just curious.
Do you know it's annually?
I think it is.
Yeah.
So
That's a huge amount of money, right? Yeah. And so the National Plan to End Parkinson's Act will unite the federal government with industry so that we're on the same page for a mission to find a cure. So we really need the government's support. And right here in the state of Connecticut, the Michael J. Fox Foundation is actively advocating for the state of Connecticut to pass a legislative bill for Parkinson's research and a Parkinson's research registry. So use your voice. If you are connected at all to anyone in government, raise your hand. If not, we highly encourage you to write into your senators and use your voice so that we can get this act passed and that the government can really help the foundation and other foundations and industry, pharma, fund treatments and clinical trials so that you are receiving, more than 40 treatments. We want to have lots of different medications for every symptom, for a cure. We want everything, and this is a huge way to get involved. But Vega and I talked a lot. Thank you all for being here and listening to us. We will open the floor to questions now, and if we don't have the answers today, please take down our contact information, and we'll be glad to follow up and send you whatever we can. Yes, we had a question. Yeah.
I have a couple of quick questions. Does the neurologist have to be the gatekeeper in order to participate in the trial?
No.
No. So in other words, you don't need your doctor's permission to participate in the trial? Okay.
Not at all.
You might want to ask their opinion, but no.
But the doctor cannot.
They
can't prevent
from, okay.
Yeah, clinical trials are not by referral.
Not
So
by referral.
I think it's always important to talk to your doctor, right? They'll be able to help you, but you do not need a referral to participate in a clinical trial.
Okay. The biomarker that you mentioned and the Atom Company gadget, are those available in clinical care, or are those not quite ready for clinical care, everyday clinical care?
So the biomarker, the SAA test,
Yep.
it is, we call it a research tool, so we're not using it for diagnostic right now.
Okay.
However, it is available. There are sites around the country. Insurance is not covering it at the moment. I forget the price. I think it's a couple $1,000s. But it is available. It is available if you had wanted to do it. But right now it's currently a research tool. I will share that we are hopeful that in the next 2 to 3 years, this will be a blood test, and it will be part of your, routine when you go to the doctor for checkups. That is our hopes and dreams, but we're probably about 2 to 3 years from that.
In the end, that Atom.
No, we're we're still waiting for final approvals on that. Gadgets are a little different than drug therapeutics because the sort of FDA approval process looks a bit different. So it doesn't take as long, and it's not as rigorous, but it's not available yet.
Two more quick, what journal was the staging published in?
Lancet.
Okay, and in the 80s, there was fetal tissue transplant research at Yale. Is Michael J. Fox looking at that at all?
So was that the stem cell transplants?
Well, they used to call it,
They used embryonic stem cells.
yes, they did.
So yeah, actually, so at the beginning, when we were founded, stem cells were sort of all the rage and they were very controversial. You know, we were founded in 2000. So yeah, that was sort of Michael just thought, I'm opening a foundation, I'm gonna be closed in 10 years, like stem cells are gonna come along and solve everything. The issue with the stem cells were that they could create dopamine neurons, but they were putting them back in a toxic environment, so they wouldn't flourish. Yeah, exactly. The alpha-synuclein created toxicity. So even if you had dopamine neurons, if you're putting them back in the dirty fishbowl, wasn't gonna work. So we have not totally given up on stem cells. They've made a certain resurgence, but we're always looking for ways to actually get them to thrive.
Thank you.
I'm just gonna say, there's no point looking at a biomarker that can early diagnosis if you're not a benefit. To find out you're gonna get Parkinson's 3 years from now, and there's nothing to prevent that from happening, because it just ruins your life for 3 more years.
I know, it's a good point, but what we need is to be able to identify people that we can test preventative trials on. That's really what we're looking for. So I hear, like with that mindset right now, I completely hear what you're saying. But what we hope is that if we find the right people, get them in the right trials, that we can change that.
I think along that line, if you're at a state where it's progressed pretty badly, are any of those metformin medications able to change that or to put you in a better place, or does it just?
There is deep brain stimulation, and you have to be a good candidate for it, but and there's also focused ultrasound. So those are basically vibrations put into the brain, and you know there's a lot of risk factors with them. But I'll also say that people who have qualified and and have received those, it has brought them back 10 years in their Parkinson's journey. I don't know if you want to add more into that.
So a lot of what we're looking at, this underlying biology, has so far shown us like progression, it kind of needs to be treated the same way, but more, you know? The same drugs, the same formulations, I should say, of drugs that levodopa-carbidopa, or if you're taking a dopamine agonist, whatever mimics dopamine in the brain, you need more of it. So it's really sort of like what's happening to you continues to happen to you. And a lot of that sheet where we were looking at the different therapeutics that are currently on market, a lot of what those are to treat certain therapies that come with advanced progression. So the fact of the matter is, like, your basic Parkinson's needs to be treated the same way. As you continue to progress and more symptoms become apparent, you have to really treat those symptoms individually, which can be exhausting, but we've definitely perfected that. You'll notice there are things like Nuplazid on there. You know, that's for Parkinson's paranoia or Parkinson's, you know, hallucinations, and it's Parkinson's specific. Rachel was mentioning, you know, there are side effects like mood. You know, dopamine's what makes us happy. Dopamine's what sort of like helps us along. But when you take an antidepressant, very often that's working with your dopaminergic system. So there are Parkinson's-specific depression medications that work with your serotonin, which is working just fine. So when we talk about progression,